ready?
Yeah.
Okay. This is, again, part 2 of the practice midterm number 1. And this is questions 45 through 48. These are more multiple choice questions where the following terms are equated for the dimensional analysis needed for these problems. And I give you, here, let me point. I have 100 microns, or micrometers, cubed is visible. 1 micrometer, a micron, is 10 to the minus 6 meters. 1 centimeter is 10 to the minus 2 meters. 1 centimeter cubed is 1 milliliter. 1.93 divided by 1.98 is 0.98. 19.3 grams of gold, of AU, is equal to 1 milliliter of AU. 1 mole is equal to 6.022 times 10 to the 23rd. 196.97 grams of gold is 1 mole of gold. 6.022 times 9.8 is 59. And you are given the instruction to fill in the bubble corresponding to the correct answer. And so we're going to be working on scratch paper a lot for these problems. But I want to tell you right up front, as should be kind of revealed if you look at the answers and notice that all this information was provided, this turns out to be an order of magnitude calculation. And that information is immediately obvious. Just this turns out to not only be a good exercise in dimensional analysis, but the rules with exponents and a comprehension of, and a cognition of order of magnitude. The characteristic term is the key, not the mantissa. These are calculations that are doable within a very short time frame. This information is readily available within a very short time frame without the need of a calculator. And these types of calculations could be done without a calculator. What would take a little more time, for example? I know you can figure out what 1.93 divided by 1.98 is. That's a simple long division question. And multiply 6.022 times 9.8 is equal to 59. But we don't really have time to waste on this particular problem doing that. This is something else we can test elsewhere in the test. But the information you're going to need to answer these questions is not going to depend upon those particular skills. This is going to depend on your order of magnitude cognition and your order of magnitude comprehension, which is going to be all about the rules of exponents. And just simply understanding the units and the unit conversion. I could have asked this whole thing in one question. I broke it up into a bunch of different questions so that you can do it in individual steps. But these could easily be strung together into one question. And I probably will show you that. In fact, I guarantee I'm going to show you that in type of an example in the next one. But it's going to be order of magnitude information we're going to be testing. So let's look at problem 45. Assuming a cube of 100 micrometers in length is visible to the naked eye, what is the volume of the cube in milliliters? Okay, so now we're going to take advantage of scientific notation and the ease of calculation that arises from using this convention. And first, well, as I go over there to work on this board, I'm going to also walk over and shut the door so we don't have the birds in the background. So, one moment. Beautiful blue sky out there. Now, assuming the cube is 100 microns in length, micrometers in length, is visible. What is the volume? So we can state the volume. What is the volume of a cube is going to be the one side times another side times another side. And we're going to express 100 microns is equal to, turns out to be 1 times 10 squared microns. And it's easiest if you express it as simply 10 squared microns, because you can multiply anything times 1. It doesn't change its magnitude. And so I'm going to use this form or this form, scientific notation, for this entire calculation. So we had first to convert that. Now let's state the volume. The volume is 10 squared micrometers, and that is cubed. So I multiply this times itself, and that gives me the volume of a cube, 100 microns, length from one side. So now I'm in cubic microns, okay? Now I need ultimately to get to milliliters, so I'm going to have to go through a couple of steps to get there. I'm going from microns, I'm going to need to convert microns to meters, and so I'm going to need a term that has meters on the top and microns on the bottom. And so it turns out that what we were given here, what were we given? 1 micrometer equals 10 to the negative 6. So there is, let's put the 10 to the negative 6 meters is 1 micron. Now, this is the conversion factor for each of these. So I'm going to need to cube it, because I'm going to have to perform that operation 3 times. Okay? And now I am in cubic meters. Each micrometer canceled each micron 3 times, and I end up with cubic meters. Now, we're going from cubic meters, I'm going to need to go to centimeters. And centimeters is, and I can go either way with the provided information. Which would I have? I have 1 centimeter, so I want centimeters on top. 1 centimeter is equal to 10 to the minus 2 meters, 1/100th of a meter. And now I have to cancel out all of these, so I'm going to have to perform this conversion 3 times. So I've cubed it. That cube seems to be the theme here, okay? And now I am in cubic centimeters. And now I need the following conversion. There is 1 milliliter for every centimeter cubed. And now we've done all the setup needed. And we've included, so on the scratch paper I've got all this stuff written out. And all the units you can see canceling each other out. Now it turns out that the only thing I've got here is either 1 or some sort of a power of 10. The units have taken care of themselves. So now, what are the rules with exponents? And let's go through and carry them out. I'm going to, underneath here, what do I do when I take an exponential number and raise it to a power? The rules with exponents require that I multiply these. So this is 10 to the 2 cubed, which is 10 to the 2 times 3, which is 6. Okay? But we're just going to track the order of magnitude here. And now I've got that, I've got 10 to the minus 6 cubed. So again, I multiply this through. This is 10 to the minus 6 cubed is 10 to the minus 18. And now I've got 10 to the minus 2, but it's in the denominator rather than the numerator, I can rewrite this as 10 to the 0 centimeters, which is the same as 1. And what do the rules of the exponents have me do when I can do this now, or I can do this in another fashion. What do I do when I divide? I subtract the exponent. So it's 0 minus a minus 2. So this is 10 squared centimeters at the end of the day per meter. And then I multiply that 2 times 3, which is 10 to the 6th. So I can call that 10 to the minus 2 cubed, but the reciprocal of that is 10 to the 6th. And this is multiplied times 1. So the order of magnitude of this, now I have to use the rules of the exponents again. When I multiply two exponential numbers with a common base, all I do is I add. Like I say all along, it all comes down to knowing when to add and when to multiply. So I add. 6 and 6 is 12. 12 minus 18 is 10 to the minus 6. So I can put that up there. 10 to the minus 6. Now let's go back over to our question. And which option was that? D. Okay? Now